welcome, and now let's talk about the first thing, and that's going to be the process of design. Now, many of you may know this process, and some of you may not, but there's a diagram we're going to be looking at, which kind of shows the flow process, and you'll notice it's a figure 4. It came out of a paper I wrote on tech transfer many years ago, and I've taught design, and I try to follow this as closely as possible because there's a discipline here, and the question is, well, where do we who are either wanting to support or put the brakes on the design of the injection of a particular technology into our culture, where do we fit in this? So let's take a look at how the designer thinks and see if that can help you in any way. So when you look at this diagram, you'll see that the first thing on the left is it's called the problem, and in that problem, there are many aspects to that problem. Of course, marketing is one. What is it that your person that's going to buy your product, whether it's a drone or whether it's a new kind of way of manipulating what's internal to a living cell, whatever the case may be, what's the character of your market? What do they really want? We know what the military wants with regard to robotic soldiers, so as designers, we will try to meet that need. We certainly have to meet a market price or the price that people are willing to pay, and so there's an economic and fiscal aspect to setting your design parameters. Design parameters are those things that say, okay, if we make this thing, it's got to meet these specifications. There's a very good process that was invented by the Japanese called quality function deployment. And if you really want to get into this, take a look at quality function deployment, because that will help you see in finer detail where you might get involved as a person who is outside of the process, you might say. Cultural issues, well, I'll tell you, most engineers don't think about cultural issues too much. Architects do, and people in industrial design do, if you look at those two disciplines. But we are more interested in making a device or a thing or software that will meet a need within the specifications that that need has to meet. Of course, science plays a role here, because what we as engineers do is take the information scientists have given us, whether it's in the biological world, how do we understand DNA, for example, and are understanding it more and more, and how it relates to how a living creature develops and its characteristics. We can say, all right, how can we manipulate that at the atomic level? And how can we manipulate a new material at the atomic level to give us the kind of strength and corrosion resistance, for example, we want, or if it's an electronic device, to have the electronic characteristics that we need by putting atoms in certain places. So science is very, very important, because that gives us the insight into nature and the natural resources that we have access to, such that we can build it. Then, of course, you find out that, gee whiz, I'm a mechanical engineer, but I got chem problems, so I better call some chemical engineers in here, and we're going to apply this to human beings, like a project I'm involved with now that I helped start, where we're looking at a robotic device to help anesthesiologists intubate a person. Well, we better have some biological engineers in there, as well as anesthesiologists and others, because, this is interdisciplinary, and there are features of this design that we don't really understand all that well. And, of course, there's government. There's the FDA and the rules they have, and environmental rules. Because we have to remember, when we talk technology, we're thinking from the gaining of the raw materials till we put them back when the device is disposed of, and the impacts of each stage through its life. Well, that helps us define our problem. And then we have alternate solutions that we should think of. Many people will say, oh, I've got the answer. First solution, they run with it. That's not the best. The best is when you come up with alternate ones. So if you have an access to this design process in any way, you can ask people, well, is that the only solution? And you toss in your ideas to change the design parameters a little bit so they have to look at it different. You can look at a coffee maker. You have coffee makers where you just dump the grounds in the pot. You have coffee makers where you have a filter and the coffee goes through the filter's stationary. Then you have the French press where the coffee's in the pot and you move the filter. So there's all different kinds. There's many ways to skin a cat, to use an old expression. Well, anyway, as you can see, you do comparisons, feedback, and you talk back and forth and look at different options. And you come to what you might call an optimal design criteria. That's part of the trick, is, of course, as a designer, to get that. And then from that, you select the solution. And you always compare your solution back to the original problem, because sometimes we get so involved with the solution that we forget about all the details of the problem. I always think of the parlor game where, you get everybody in a circle, and the first person whispers a little story in the ear of the first person, and then that person whispers in the ear, and the others goes all the way around. And then when the last person, after they've had it whispered in their ear, tells you what the story was, and you compare with what went in versus with what came out. And generally speaking, it's not the same. So the same thing happens in corporations and businesses and with designers and everybody else. Okay, then you begin estimating the impact, because that's going to have a result on the solution you pick as well. Now, here's where you really can begin to play a role. You see this coming. You have some idea as to what that impact might be relative to what you think is a good life, or what's right and wrong for society to do or behave. And at that point, you can begin getting some input in there. You make yourself heard so that they want to listen to you. We're going to talk a little bit about this as an example. The Defense Department is working on making autonomous, self-thinking robots take the place of soldiers. Well, that sounds okay. Human life is preserved and that sort of thing, or it isn't as much in danger. But, there's a group in England that said, wait a minute, we don't think this is a good idea, because there will be negative consequences here that we aren't thinking about. And so they've tried to go to the British government. They've gone to the United Nations. They say, we want to be heard. They're wanting to have their opinions incorporated into the design process. And it's interesting that we just finished a class in this same topic that we're dealing with here at the university, and the students were asked to write a paper about what they thought about the use of robotics soldiers that are autonomous. And here's what one of them wrote, which I thought was quite insightful, and I'll close with this. They said, yes, indeed, life of the typical soldier will be saved, and that is good, because killing and loss of life or limb is not good. But that's what makes war horrible. When we see what happens to human beings, that's what makes war horrible. Now, if it's only machines that are getting hurt, that's the machine. We can rebuild the machine. We can, it's just a loss of money. And the net result is going to be a greater desensitization of humanity relative to the value of life. I had never personally thought of that, but these students said, that's what these people in England are saying, and they need to be heard. So there's a good example of, you want to get in the design process, you can't do it as an individual, get in a group, get in a network, so that you can be heard. The network they're getting into is international affairs by going to the UN. The network they're getting into is the government regulatory bodies. And once they're in that network, then maybe they can be heard. And you may remember when I talked about the solar-powered satellite, how it got started, how it got funded. It was because one man who had this idea kept wandering around the government, getting into that network, convincing him it would be an interesting research project, and it began. So it's not hopeless, and you can do it, but be aware of how this design process works so you know where to get yourself into it. And with that, I'll close, and we'll see you again shortly.